Greetings, programs. I'm the original gamer, Stevie Stroh, and we are back for another exciting adventure in programming on the color computer in BASIC. This is episode 2 covering chapter 2, and what we're going to talk about today is how to store information in your computer's memory, how to store this information, and how to have this information relayed back to us at a later time.
Hey, you got your Coco 3 yet?
So we're going to go ahead and just get into this, and this is starting on page 19. This is chapter 2, and it says here that one skill that makes your computer so powerful is its memory. Have it remember the number 13. Type in A equals 13. So let's go ahead and do that right now. If we type in A equals 13 and we hit enter, the computer says OK. And so now it says try to confuse your computer by typing whatever you want. When you're done, press enter. See if your computer remembers A by typing in print A. So if I say, hey computer, look over there, it's Donald Trump, and I hit enter, computer says, dude, I don't know what you're talking about. I tried to confuse it, but if I say print A, it still remembers that A is the number 13. The computer will never forget what you tell it, and unless one of two things happens, that you tell it something else or the computer loses power. So if we tell the computer that A is 13, the computer will remember that forever unless we say A is something else or we lose power. Computer is not like a person. Me, you tell me something and all of a sudden I see something shiny, I'm kind of like...
I'm trying to think, but nothing happens.
I just don't know. I will be very easily distracted and I can very easily forget something. However, the computer will not do that. Now it says that... your computer is going to remember A is 13 as long as you have it on or until you do this. Type in A equals 17.2. And now that I've done that, the computer says, okay. And now it says print A. If I say print A, guess what? A is showing up as 17.2. So what it's saying here is that originally in your computer's memory, A was 13, but now in your computer's memory, A is 17.2. Now look at this little picture here. This picture here does a really good job of illustrating the concept. You see the computer looking at these kind of like filing drawers here, these little boxes. The boxes on the left have letters, and like A, B, C, and those letters contain a little card that has a number on them. The boxes on the right have letters with dollar signs, which we'll get into in a minute, and then in there are little cards with words with quotes around them. So this picture is going to illustrate the concept that chapter 2 teaches us. So we have told the computer that A equals 17.2 now. Now it says that you can... you don't only have to use the letter A, you can use any letters from A to Z. In fact, you can use any 2 letters from A to Z. So now it's saying type in this. It says type in B equals 15, type in C equals 20, and type in BC, Bravo Charlie, equals 25. After each line, the computer says OK. There's a little side note here. It says if you already know BASIC, you may be accustomed to using the word let before this command line. The color computer doesn't let you use the word let. So I remember this in some of the older computers like the Apple and Atari. We used to have to say let A equal 5. You don't have to say let, you just say A equals 5. So we've now just set up a handful of variables in the computer. We've set up some memory locations. We've said A equals 17.2 all the way down to BC equals 25. And so now it says have it print all the numbers that you have asked it to remember. Type in print A, comma B, comma C, comma BC. So if I do that right now and I say print A, comma B, comma C, comma BC, I'm asking the computer to print out what has been stored in its memory. So if I hit enter, it has printed out the A. See right here it says print A. Up here on the screen we said A equals 17.2. We can see that here. Here we're saying print B. Up here we said that B equals 15. We can see that right here. Right here we're saying print C. We can see here we said C equals 20, which we can see there. Finally we're saying print BC. Here we told it that BC is 25 and we see it there. These commas in between the A, B, C, and BC are basically telling the computer to print these things into columns. And so it's printing them out in columns and then it's wrapping it to another line. So we've just had it print out information that we specified in its memory. We put information in the computer's memory. We then said, show us back what you remember. And now it says if you want the computer to remember a string, and if you remember from chapter 1, a string is text that's wrapped in quotes. If you want the computer to remember a string of letters or numbers, use a letter with a $sign for the variable. So if we type in a string, which is a $sign, equals quote, try to, as it's asking us to do, and then we say b string equals quote, remember, and then it's saying type in c string equals quote, this comma space u quote, and then finally bc string equals great computer quote. We have just defined 4 string variables, a, b, c, and bc. And now it says print these out and have the computer print them for you. So if I print a strings, comma b strings, comma c strings, let's get the right character in here, comma bc strings, and I hit enter, it is going to print out what it stored in memory. Try to remember this, you great computer. These were strings that we set up in memory. These were pieces of information we had it store, and we can now have it display back what it has stored for us. And so it says here that computer types have a name for these letters we've used that we call variables. And computer types would be us. We are the computer type of people, right? So far we have set up these variables in your computer's memory. We've set up A is 17.2 and so on. We set up a string is try to remember. So it's showing us a little thought balloon here, trying to visualize what's in the computer's memory. We have plugged a bunch of stuff into memory. We've asked it to do things, but it says, how about you spot check your computer? If the computer tries to remember something, for instance, let's see if BC is still 25. So if I say print BC, it's still 25 because it hasn't changed. We have not told the computer that BC is anything different than when we first told it. So information that's put in memory stays in memory, and that information will not change unless we change it or the computer loses power. And so down here, the example it's giving you says think of variables as little boxes in which we can store information. One set of boxes is for strings, the other set of boxes is for numbers. Each box has a label, and that picture I showed you earlier with the little file drawers is a great visual analogy of this concept. But it does say that you have to follow rules. Computer is fussy about rules. Computers are fussy about everything. Computers are very literal. Computers want things exactly as they are supposed to be, and computers don't accept too many exceptions. So now it's saying, do you think the computer is going to accept these lines? If we type in D equals quote 6, will the computer accept that? No, it does not. If we say Z equals quote, this is string data, will the computer accept that? No, it will not. It says the computer responds to both lines with a TM error. It's telling you that you have to play by its rules. TM is an abbreviation for type mismatch. This is an error the computer is telling you, saying, this is not a syntax error. Syntax error says, I have no idea what you just said. Type mismatch error says, I have an idea what you're trying to do, but you're not.
Let the Radio Shack TRS-80 put the world of color computing into your home. Instant loading program packs turn any color TV into an exciting game arcade. And there's more. The color computer is an educational aid, a home management tool, and up-to-the-minute electronic information service. The programmable, expandable TRS-80 Color Computer from $399 only at Radio Shack, the biggest name in little computers.
You're not quite doing it correctly, so try again, sucker. So what this is illustrating to us in this example here is that when you are dealing with quotes, we're dealing with a string of text, you have to have a $sign after the variable name. So the fact that this D did not have a $sign means we cannot use quotes. So that's an incorrect statement we're giving the computer. Same thing here with Z. Because we've put quotes around something and there's not a $sign, we cannot put quoted or string data into a variable that does not have a $sign associated with it. That's what it's trying to tell us here. So it basically is telling you the rules that any data in quotes is a string data, and you can assign string data to a variable with a $sign. Those are the rules. So it says if you want it to obey, to make the above lines obey the computer's rules, use a $sign. So if I go back in here and I say D string equals quote 6, that says okay, that's fine. If I say Z string equals quote, this is string data, that says okay, that's fine. So strings and $signs go together. Quotes and $signs are part of a string variable. So now it's asking us to go in the other direction. Let's try to assign something to a string variable that does not have quotes around it. So if I say D string equals the number 6 and hit enter, once again, I'm going to get a type mismatch error because I'm going the wrong way, but I'm still going incorrectly. When I'm dealing with a string, there must be quotes around the variable. The fact that there are no quotes here means that the string is not going to work. So the rules for numeric data are that numbers not in quotes are numeric, and that numeric data can only be assigned to variables without a $sign. So summary there, $sign in quotes is strings, no $sign, no quotes is numbers or numeric. So if we go back here and we say D equals 6, and then we say Z equals 12, computer's like, okay, that's fine. And now it even says here, we have now added this to your computer's memory. In your computer's memory, it knows that D is 6, Z is 12, D string is 6, and Z string is this is string data. The next thing it's going to show us here is that we can actually perform math based on variables. And for those of you who took math in school, this is what is known as algebra. And this is when algebra started to make sense to me. I started programming in probably what you would call junior high or middle school. And I didn't like math. I wasn't good in math. But using the computer, following this book, and then getting into algebra classes, things made more sense because I had a context in which to put these things into. So when we are dealing with variables, where right now it's saying print D times 2, and the computer uses the star for the multiplication symbol, not the letter X. So previously we told it that D equaled 6. So we've assigned a variable. Now it's saying to print D times 2, which is saying basically multiply the variable D times the number 2. And the computer did the math, and the answer is 12. So 6 times 2 is 12. And so what this is showing us is that the computer can take information that's stored in memory and take these variables and then use these variables in a lot of different ways. Use this information that's stored and do math on it or do other things with this information. And the computer will never forget what you tell it, and the computer doesn't make mistakes on when it does its math, unlike us humans. Now the next thing it's asking us to do is to try a division exercise. It's saying print Z divided by D. Right here we had told it that Z equaled 12 and that D equaled 6. So when I say print Z divided by D, and in the computer the division symbol is the slash, I'm basically saying what is 12 divided by 6? That answer should be 2, which is basic math. So in this example here, we're showing that the computer can store numeric values in a variable, and then we can take these variables and we can do math on the variables, which is pretty cool. And that's basically computer algebra. So now it's saying the computer prints the quotient of Z divided by D, which is the answer. Now it's saying, would this work? Can we print D strings times 2? Well, let's find out. Print D strings times 2. And that answer is no. That is a type mismatch error. Did you try it? This makes the computer print the same TM error. It cannot multiply string data. The next thing it's asking us to do is to cross out things that will not work. So in this example here, it's saying F equals 22.9 repeating. Will that work? That answer is yes. F is a numeric variable because there's no $sign, and we're assigning a numeric value to it. The next one is M equals quote 19.2. That will not work. We can cross that off. 19.2 is in quotes. That's string data. String data can only be assigned to a variable that has a $sign next to it. The next one says DZ string equals remember this for me. That will work. It's a string variable with string data. The next one says M string equals 15. That will not work. A string variable requires quoted data, and there's no quotes around the 15. And then the last one says Z equals F plus F. That will actually work because we are taking a numeric variable and we're adding other numeric variables to that. So that is numbers plus numbers. That will always work. And so it says the commands that the computer will accept are the ones we just mentioned, the F, the DZ, and the Z. Those will all work. But I want to illustrate that concept right now. Right now, if I said print Z, because that's the only way we can, and at this time, get the computer to tell us what it remembers the variable Z is. Right now, it says Z equals 12. In this example here, even though it didn't ask us to type it in, I want to illustrate this. This is saying Z equals F plus F. Well, what is F? Because I don't think we've defined F. Well, if I'm not sure what F is, if I type in print F, the computer is going to tell me what it thinks it is. In this case here, it's saying F is 0. And the reason why is that we have not defined F. We have not given F a value, and any variable that has not been declared or defined is automatically assumed to be 0 or nothing in the computer's mind. So right now, F is 0. And if I was to type in that command that the book just told me here, which is Z equals F plus F, which I'll do here just for grins and giggles, the computer now says OK, but if I print out Z, Z, what are you now? Well, Z is 0 because F was 0, and 0 plus 0 is always going to be 0. So that is just illustrating the point that if you either intentionally or unintentionally add variables that have no value, you can potentially change the values of other things and even wipe out information in memory. So the rules on variables are summarized here. You may use any two characters from A to Z for a variable. The first letter must be a letter from A to Z. However, the second letter can be either a number or a letter. If you want to assign string data, put a $sign after it. Otherwise, it will only hold numeric data. So there you have it, folks. We have just wrapped up Chapter 2, which is dealing with assigning information to memory, storing it in what we call a variable. And a variable is like a box or a container of information. And variables come in two flavors. There are string variables, which contain text, and there are numeric variables, which contain numbers. What I'd like to do before we end this video is I would like to take all of the concepts we discussed in Chapter 1 and Chapter 2 and put them together and do our first program. Are you ready to do a program, boys and girls? All right, well then let's go ahead and do that.
At GSoft, we make games for the TRS-80 Color Computer, TRS-80 MC10, and Dragon computers. Our basic games cover the range of genres from arcade, to text adventures, to simulations, to 3D dungeon crawls. This is our latest puzzle game from Japan, Fruit Panic. So come on and drop by our website and download our latest games.
Because this is a series on programming, why not write a program, right? That is the goal here. We're going to learn the language, and we are going to use this language to write a program, eventually write a video game. And I'm also going to jump ahead just a little bit, and I'm going to introduce you to a command or a word in the computer's language that we haven't read about just yet in Chapter 1 or 2. But I'm going to tell you how to have your computer generate numbers for us using the random command. So if you look back here on the screen, you will notice that every time I typed something in, we either got a valid response that said OK, or we got an invalid response. So when I said print Z, it gave me the answer and then it said OK. When I said print F, it gave me the answer, it said OK. We have been doing this in a kind of an interactive mode where I type in something, the computer responds back saying that's good or that's not good. So we've been kind of interactively talking to the computer one command at a time. And this is talking to the computer in its language, but this is not necessarily writing a program. In order to write a program, we have to put line numbers in front of these statements. And when I start doing the line numbers in the statements, you'll see that the computer is not going to say OK after each one. And I'll give you a perfect example right now. We're going to start off with line number 10, which is the first line of our program. And we're going to assign a variable for color. We're going to say C equals for color. And this is the new command I'm going to introduce you to, which is RND for random. And we're going to say pick a random number between 1 and 9, because the computer actually can change the screen to 9 different colors. Now, because one of those colors is actually 0, we're going to do a little algebraic formula here. So we're going to say randomize a number between 1 and 9, and then I want you to subtract 1 from that number. So this would be like me, person Steve, saying to person you, hey, do me a favor, think of a number between 1 and 9. You got it? Okay, now subtract 1 from that number. That's what I want you to think about. So I've told the computer to pick a number out of the hat between 1 and 9, and whatever that number is, subtract 1. So if the computer picks 1, you subtract 1, it will be 0, which is actually the color for black. If the computer picks 9, it will subtract 1, which is 8, which is the highest color on the computer. I think that was the bright orange color. So this first line is telling the computer to basically pick its own variable. In this chapter, we have been assigning variables. We've been typing numbers in and telling the computer this variable equals this number, or this variable equals this text. We're now doing something a little bit different, where we're asking the computer to use its own imagination and think of something for itself. And the ability for the computer to generate things randomly was one of the easiest ways for me to make games without having to write advanced logic. By having the computer randomize things for me, I could make things appear on the screen in random fashions that I didn't have to think about. The computer thought about it for me. So we're going to pick a random color. The next thing we're going to do is we're going to pick a random sound. If you remember, Chapter 1 dealt with the sound command, and the sound command can generate a tone between 1 and 255. So we're going to say T for tone equals random 255. And the way the random command works is it will always pick between 1 and whatever number you have in parentheses. So I'm basically saying for the variable T, pick a number between 1 and 255. The next thing we're going to do is we're going to pick a length. And we're going to say the length equals random 24. Just out of the hat here. And that's how long the note is going to last when it makes a note. So these first 3 lines of code has said pick a color, pick a sound, pick how long you want that sound to play. And those are now variables. Those variables only exist in the computer's memory. To get it out of memory and get it onto the screen, we have to then say, take this information, present it to us in a way that us humans can understand. So the first thing we'll do here now is we're going to clear the screen in the color of C. Whatever number the letter C, the variable C, gets to be generated as, we're going to clear the screen in that color. The next thing we're going to do is we're going to use the print command, which was covered in Chapter 1, and we're going to say color equals. We'll end the quotes, and then we'll put the letter C after that. And so this will actually print out the word color equals, followed by the value of C, which will be whatever random number it makes. The next thing we'll say in line 60 will be print tone equals. Let's space this out where it's the same. Tone equals T. And that's the random tone that it generates. In line 70, we'll say print length, Length, equals, quote, L. And so I've just kind of spaced these things out where the equal sign is the same in all 3. So what line 50, 60, and 70 say here is that we're going to print the word color in text, followed by the value of whatever that variable is for color. We're going to print the word tone in text, followed by the value of T, and then we're going to print the word length in text, followed by the value of L. Now what we need to do in line 80 is we now need to make it actually generate the sound. So we're going to use the sound command, and then we're going to say sound off on the number that T was, whatever tone you picked, for the length that we also picked. So we're going to say sound T, comma, L. And these are variables. So whatever tone is picked out of the hat will be played for the length that was picked out of the hat. This is all done randomly for us using the random command. And now this will happen one time but I want it to run forever. So line 90 is going to say go to 10. So the computer is going to process this from top to bottom. It's going to start here. It's going to generate a random color, generate a random tone, generate a random length. Next, it's going to clear the screen with that color. It's then going to print some lines of information on the screen. It's then going to make a sound. When it reaches line 90, it's going to say go all the way back to 10. And this is going to keep happening around and around and around. And this is what's known as an infinite loop. When you have a program continue to repeat itself. So now you'll notice that I've been typing in all these commands. The computer never once said okay, 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 okay. We're not in interactive mode right now. We're in programming mode. And so now that I've given it all this information into my program, the only way to see the computer execute this or to run this is to type in the word run. Hey guys, it's the original gamer Stevie Stroh here, and I want to talk to you about the Coco Crew podcast, hosted by John Linville and Neil Blanchard. It is a delicious journey into retro computing featuring the Tandy Color Computer. So if you are into vintage computing, retro computing, old school gaming, and especially if you're a Coco nut who's into the color computer, you gotta check out the Coco Crew podcast at cococrew.org, also available on iTunes and Stitcher. And tell them the original gamer Stevie Stroh sent you. We are now going to run our program, and when I hit enter, what we are now seeing is the fruits of our labor. We are seeing everything we learned in Chapter 1 and Chapter 2. We're seeing that we can print text and numbers together side by side. We are seeing that we can put colors on the screen using the CLS command, and we're seeing that we are generating sound using the sound commands, and we're doing all of this with the concept of the variables that we learned in Chapter 2. The only thing I threw you as an advanced concept was the command to randomize these variables so we don't have to do it ourselves, and the random command will be discussed in a later chapter. So there you have it, folks. This completes Chapter 2 of Programming the Color Computer in BASIC. Did you enjoy it? Oh, I am so glad that you did. So let me know what you think of this series and of this video, and I look forward to more of these in the future. Let me go ahead and break out of this. To break out of this on a real color computer, you would have to hit the break key. Since we're using an emulator, I believe it's the end key. Yes, so if you hit the end key on your keyboard, you have broken out of the program. So that's it. That completes Chapter 2. I hope you enjoyed this video. I hope you're enjoying this series. Please leave me a comment, send me some feedback, tell me what you thought. You can find out all kinds of ways to reach me on my website, ogsteviestroh.com, including links to all kinds of cool color computer stuff, including the links to download the emulators and the manuals you need to do this series with me. I will see you all next time, but until then,
End of line.
End of line programs. I hope you had as much fun watching this video as I had making it for you. And if you did, then do me a favor and smash that like button and subscribe to this channel. If you've got something you'd like to say, throw out a comment and let me hear it. I'd really appreciate it if you could share this video and my channel with your friends. So thank you so much for watching. I'll see you all next time. Peace out, bye-bye, and long live the Coco.